The night sky seems motionless, yet everything is quietly drifting apart, like boats carried by an unseen ocean. Stars grow old, galaxies sigh, space itself expands like a memory that refuses to fade. This video does not only ask how the universe is moving, it promises to touch something deeper, the final destiny of all things. Leave your thoughts below, as if sending a message into the void. And now, let us move forward together, because if everything is moving, where is it going? If everything is moving, what is the destination, and who decided there had to be one in the first place? Stand under a winter sky and it feels like a painted ceiling, calm, fixed, eternal. Yet the truth is stranger and more intimate. The entire scene is in motion. Not only the stars sliding through their ancient patterns, but the very stage they hang upon, stretching, thinning, drifting, as though space itself is breathing. And with every breath, everything is carried a little farther from everything else. We live inside a story that refuses to hold still. And the question you asked, if everything is going, where is it going, is not poetic decoration. It is one of the cleanest scientific questions a human mind can form, because it forces us to confront what going even means when the road is the universe itself. To begin, we have to separate two kinds of motion that our instincts love to confuse: the motion of objects through space and the motion of space itself. Galaxies are not simply flying away like sparks from a firework. The distances between them are growing because the fabric between them is expanding. The simplest picture is still one of the best. Imagine dots on the surface of a balloon. As you inflate it, every dot recedes from every other dot. Not because any dot is running, but because the surface they share is swelling. And from the perspective of any one dot, it looks like it is the center, which is exactly the weird humility of cosmology. Every observer can honestly say, everything is moving away from me. But then, the mind reaches for the next question. Expansion toward what? Into what? Where is the edge? And here, the universe gives us its first hard lesson in intellectual discipline. It may not have an into that matches our everyday intuition. The balloon analogy helps us see the pattern. But the surface of the balloon is not expanding into a direction that exists on the surface. The into belongs to a higher dimension we do not live in. And so, when you ask where everything is going, the universe may answer. It is going into a future you can measure, but not a place you can point to, and that is not a cop-out. It is a clue about the limits of the metaphors that carried us this far. Now, if expansion is the stage movement, the next layer is the plot. And the plot has a name that sounds cold, but describes something deeply human. The arrow of time. Sir Arthur Eddington gave it one of its most famous formulations when he wrote, "Let us draw an arrow arbitrarily," in Amenders, and then tied the future to the direction in which randomness increases. This is not merely abstract philosophy. It is why a shattered glass does not leap back onto the table. Why smoke does not neatly crawl back into a cigarette. Why your childhood does not return with the precision of a rewound film. Time does not just pass. It passes in a direction that leaves fingerprints. And those fingerprints are written in entropy. The tendency for energy to spread out. For differences to smooth away. For concentrated order to dissolve into distributed possibility. To make that real, picture a drop of ink falling into a clear glass of water. At first, it is a dark, elegant bruise in the transparent world. Then it blooms, curls, threads, disperses, until the water is uniformly tinted and the original drop is no longer a drop, but a memory. Could the ink spontaneously reassemble back into that first concentrated bead? In the strict laws of microscopic physics, it is not forbidden in principle. But in the statistics of the real universe, it is so fantastically unlikely that you will wait far longer than the age of the cosmos. And that is the point. The universe does not need a law that says, things must get messier. 8. It only needs a universe with countless particles and countless possible arrangements, and the relentless mathematics of probability does the rest. As Stephen Hawking put it with his characteristic bluntness, the universe doesn't allow perfection. End quote. Well, isn't as aggression. And now we can connect the feeling of going to something more precise. The universe is not only expanding, it is evolving toward states in which usable energy is harder to find. The cosmos began in a condition of extraordinary smoothness and astonishing potential. And everything we love, stars, chemistry, life, thought, emerges because there are gradients, differences, hot and cold, dense and thin, that can be exploited. A star is a machine that runs because gravity and pressure are locked in a long negotiation, burning fuel into light. And every photon it releases is a tiny payment to entropy, a tiny spreading of energy into the wider dark. So when we ask where everything is going, one sober scientific answer is this: it is going toward a future where gradients fade, where the universe becomes more uniform, more diluted, less able to build new complexity. This is why cosmologists sometimes talk about a heat death. In an ESCO, a phrase that sounds melodramatic but is almost painfully quiet in its meaning. It is not an explosion. It is not a scream. It is a long exhale. A future where stars burn out, galaxies drift apart, black holes evaporate on timescales that dwarf imagination, and what remains is a thin sea of low-energy particles and faint radiation, a universe that still exists, but no longer does much. If the cosmos were a symphony, it would be the moment after the final note, when the hall is still vibrating but the music is gone. Yet science, at its best, is not a single prophecy but a disciplined catalog of possibilities. And here, the universe offers not one ending but several, each one a different answer to your question, and each one shaped by something we are still measuring with ever greater care. The nature of dark energy, the mysterious driver of cosmic acceleration. If dark energy remains constant, expansion continues. Galaxies beyond our local group slip over the horizon of what light can ever reach us. And the night sky grows lonelier over unimaginable time. If dark energy strengthens, the story turns violent. A big rip. 7. In which expansion accelerates so ferociously that it overcomes not only galactic gravity, but the binding of atoms themselves, tearing apart stars, planets, molecules, and finally the fabric of matter. And if dark energy changes sign or fades, gravity could one day slow expansion, halt it, and reverse it, drawing everything back toward a big crunch. Thanks for watching. A closing fist after an opening hand. And then there is a quieter, more eerie possibility. Vacuum decay. The idea that what we call empty space may not be in its most stable state. That the vacuum could be a false plateau. And that a lower energy state could nucleate somewhere, forming a bubble that expands at near light speed, rewriting the laws of physics as it goes. No warning. No drama you could see in advance, just the sudden fact that the rules you lived under were provisional. This is not presented as doom, but as humility, a reminder that our best models still leave room for surprises. So where does that leave your deeper question? Maybe going is the final nature of the universe. Maybe there is no terminal harbor, only the current. On the largest scales, the universe smooths out, spreads out, thins out. Yet locally, it builds. It clumps. It forms stars and worlds and minds, like a river that as a whole runs downhill while forming eddies that briefly swirl upward against the flow. Life may be one of those eddies, a temporary island of order that exists precisely because the larger universe is increasing entropy. A candle flame is organized, bright, and structured, but it can exist only by consuming fuel and dumping heat into the room. It is a beautiful rebellion that still obeys the overall direction. This is where a line from Carl Sagan lands with unusual force. We are a way for the cosmos to know itself. In 70 film business, it is need happens of the channel, 5 or 10ths of the J's discoms, because if the universe is going toward a future of wider dispersal, then awareness is one of the rare moments where the universe gathers itself into a question. The hydrogen in your body was forged in the early universe. The carbon in your cells was cooked in stars. The iron in your blood was born in explosions. And now, arranged into a nervous system, it asks where it is going. And finally, let me hand the question back to you. Not as despair, not as comfort, but as awe. If everything is moving, galaxies, time, energy, even the fabric of space itself, then is the destination a place? Or is the destination simply the fact that it goes? What if the galaxies are not running away from us at all? What if nothing in the universe is truly fleeing? What if the space between everything is simply learning how to breathe? When we look at the night sky, it feels calm, anchored, almost eternal. Stars seem pinned to the darkness like memories that refuse to fade. But that stillness is a trick of perspective, because behind that quiet image, space itself is stretching. Galaxies are not engines racing through a fixed void. They are passengers carried by an expanding fabric. The universe is not throwing matter outward. It is gently pulling the stage apart beneath it. This idea feels backward at first. In everyday life, motion always has a direction. A train moves along tracks. A river carries leaves downstream. There is always something solid beneath the movement. But in cosmology, the thing that changes is not the object, it is the distance itself. Imagine drawing 2 dots on a rubber sheet. Now stretch the sheet. The dots move farther apart without moving across the surface. From each dot's perspective, the other dot is receding. Neither is the center. Neither is responsible. Expansion happens everywhere at once. This is why astronomers say something so strange and so precise that the farther a galaxy is, the faster it appears to be moving away. Not because it is accelerating through space, but because there is more space being created between us and it. And here is where the paradox begins to deepen. The farther we look, the older the light we see. Distant galaxies show us the universe as it once was, younger, hotter, closer together. Yet those same galaxies are now so far away that their light, emitted today, will never reach us. So the act of looking far becomes an act of loss. We see what once was reachable. We know it is no longer within reach. Picture standing on a shoreline at dusk. A boat drifts away, not because it is rowing, but because the tide is pulling the water outward. You can still see the silhouette. You can still remember its shape. But no matter how long you wait, it will never come back. This is not just poetic language. It is the literal structure of our observable universe. There are regions of space already beyond our cosmic horizon, places whose light will never arrive here, no matter how long the universe exists. And that realization quietly reshapes how we think about knowledge. Because science is built on observation, and observation now has a boundary. The universe is not only vast, it is selectively accessible. Some truths are visible only for a limited time. Some chapters close not with explosions, but with distance. This expansion also teaches something humbling. No galaxy is special. No location is privileged. Every observer sees the same pattern. Everything else moving away. The universe offers no center to stand upon. Yet, strangely, this does not make existence meaningless. It makes awareness precious. We live in an era when galaxies are still visible, when stars still burn, when the universe still allows itself to be studied. There will come a time, Far in the future, when observers, if any remain, will see only their local island of stars, surrounded by darkness, they may never know the universe was once filled with galaxies. They may never infer expansion. They may believe they are alone in a static cosmos, which raises a quiet question for us. Right now, if understanding is temporary, does that make it less valuable, or infinitely more so? Because the universe is not rushing anywhere. It is unfolding, and we are living inside a rare moment when its story can still be read. The deeper truth may not be that the universe is moving away from us. It may be that we are witnesses standing at the edge of a vanishing view. And if space itself is growing, if distance itself is being created, then the real question is no longer how fast galaxies recede. The real question is this: if everything is drifting beyond reach, what does it mean that we are here to notice it? What if the strangest thing about time is not that it passes, but that it only ever seems to pass one way? You can rewind a video, but you cannot rewind your life. You can unspill milk in a film, but you cannot unspill it on your kitchen floor. So here is the hook that should bother you, in the sweetest and most unsettling way. If the universe is ruled by laws that often look reversible on paper, why does your experience never run backward? Imagine holding a warm mug on a cold night and feeling the heat seep into your fingers. No one has ever watched the cold crawl back out of their skin and leap neatly into the cup. That one simple fact is a doorway into a deep idea physicists call the arrow of time. Not a literal arrow, but a direction etched into reality, pointing from what we call past to what we call future. And in that direction, memories collect only behind us, never ahead. You can feel the arrow in your own body. A child becomes an adult, a candle burns down, a bruise fades, a page turns. Your mind stores yesterday like sediment on the ocean floor, layer after layer, while tomorrow remains a blank sea that has not yet touched the shore. That is not just poetry, it is physics wearing a human face. Because when you ask why memory only points backward, you are really asking why the universe itself has a preferred direction. Here is the twist, and it is beautiful. Many of the fundamental equations of physics do not care which way time runs. In the mathematics of motion, you can often flip the sign of time and the rules still work. It is as if the universe can read the script forward or backward, yet we only ever see one version performed. So where does the one-way street come from? Where does the arrow hide? To find it, we follow something that sounds dry but feels like destiny: entropy. Entropy is often described as disorder, but that word can mislead. A better story is this: entropy measures how many different microscopic arrangements can produce the same macroscopic scene you can see. A neat deck of cards has fewer ways to be neat than to be shuffled. A pristine sandcastle has fewer ways to be intact than to be collapsed into a beach. So time seems to move in the direction that makes more and more arrangements possible. Not because nature loves mess, but because nature has more ways to be ordinary than extraordinary. The physicist Arthur Eddington put it starkly, almost like a verdict. He said that the law that entropy increases holds the supreme position among the laws of nature. That is not just a technical claim, it is a narrative claim about the universe. It suggests the arrow of time is not primarily about clocks, but about change becoming statistically inevitable, and suddenly your spilled milk returns to its rightful place in the story. Not as a minor annoyance, but as a signature of a cosmic rule. Now let us step gently from the kitchen to the cosmos. Look up at the stars, and you are looking at furnaces that burn in one direction. A star takes hydrogen, and, through nuclear alchemy, turns it into helium, releasing light and warmth. You never see a star gather its scattered radiation from space and reassemble it into fuel. In that sense, stars are time machines that only run forward. They turn low entropy fuel into higher entropy light, spread thin across the sky. That spread is the arrow made visible. And yet, you might say, if entropy explains the arrow, why did the universe begin in a state where entropy could increase at all? Why was there room for the arrow to point forward? This is the real mystery. The arrow of time seems to depend on the universe having started in a special condition, a low entropy beginning, a beginning that was strangely ordered, strangely smooth, strangely quiet in certain ways. It is as if the cosmos began with the deck unshuffled, and from that first moment, everything we call history is the long, irreversible shuffle. Stephen Hawking once summarized this with a clarity that feels like cold air. He said, "The increase of disorder, or entropy with time, is what we call the arrow of time." But Hawking also pushed us toward the deeper question of why the universe had such a low entropy start. Because if the start had been already maximally scrambled, there would be no meaningful direction, no gradient, no story. There would be no memory, no aging, no evolution of complexity, just a static sameness. So when you ask whether the universe has a future that grows old like a human being, you are really asking if the cosmos has a biography. Does it have youth, maturity, exhaustion? Does it have seasons? In a way, we already know it does. The universe had an era when it was too hot for atoms. Then it cooled, formed hydrogen, lit the first stars, assembled galaxies, forged heavy elements, and eventually built the chemistry that could become life. That sequence is not random, it is directional. It reads like aging. But cosmic aging is not about wrinkles. It is about energy becoming less concentrated, less available to do interesting work. At the beginning, energy differences were sharp, like steep mountains. Over time, those mountains erode into gentle hills. Temperature differences fade. Matter clumps and burns. Stars consume their fuel. Black holes swallow structure. Radiation stretches and thins. The universe slowly spends its ability to create dramatic contrasts. Here is an image you can hold. Think of a brand new battery. It has potential, stored separation, a promise. As you use it, the charge spreads out, becoming more uniform until there is nothing left to power a light. The universe is like that battery on a cosmic scale, not in a simplistic way, but in the sense that the early universe had usable gradients, and the future tends toward equilibrium. And equilibrium, in physics, is a kind of quiet. This is where education becomes emotional, because the arrow of time is not just a theorem, it is the stage on which meaning performs. Memory is possible because the past leaves traces. A footprint in dust, a ripple in water, a scar in stone, a pattern in neurons. Those traces are physical records created by irreversible processes. A camera sensor records light because photons are absorbed and converted. A brain forms a memory because chemistry changes. A book holds a story because ink was fixed onto paper. Every record is paid for with entropy. To remember is to participate in the arrow. You can see this in a simple example. Strike a match. For a second, the flame blooms like a tiny sun. Then it is gone, leaving smoke, heat, and ash. That is time. Now imagine trying to reverse it. You would need the ash to gather itself, the smoke to funnel back into the wood, the heat to pull itself from the room and concentrate into the match head. The laws do not forbid it in principle, but the odds are so impossibly small that it will never happen in the age of the universe. The arrow is not a lock, it is a mountain of probabilities. Ludwig Boltzmann, one of the founders of statistical physics, gave us the bridge between microscopic reversibility and macroscopic irreversibility. His work whispers a profound lesson. Order is fragile because it occupies a tiny island in a vast ocean of possibilities. Disorder is robust because it has countless ways to exist. So, the arrow of time is not merely a philosophical feeling. It is a statistical pressure built into the combinatorial architecture of reality. Now, let us return to the human question hiding inside your scientific question. If the universe ages, what does that mean for us? It means we are not outside the story looking in. We are a late chapter written by stars. The carbon in your cells was made in stellar furnaces. The oxygen you breathe was forged and scattered by dying suns. Your nervous system runs on gradients, on differences, on energy flowing from concentrated sources to diffuse sinks. Even your thoughts are powered by the same cosmic rule. Energy flows, entropy rises, time has direction, and consciousness rides that direction like a boat on a current. Albert Einstein once wrote a line that people repeat because it feels comforting and because it feels haunting. He said the distinction between past, present, and future is only a stubbornly persistent illusion. Read gently, that does not mean your life is meaningless. It means our everyday sense of time may not map perfectly onto the deeper geometry of space-time. Yet even in that deeper view, the arrow of entropy still gives our lived experience its undeniable forward push. So there is a tension worth holding. Physics can suggest time is woven into a four-dimensional fabric, while thermodynamics tells us why our minds experience a one-directional journey through that fabric. And this is where the story becomes meditative, because the arrow of time is not just out there among galaxies. It is in your breath. You inhale ordered chemical potential in food and oxygen. You exhale warmer, more diffuse air. You take concentrated energy and turn it into movement, warmth, thought, and finally into a gentler spread that disappears into the room. Life is an island of local order that survives by exporting entropy to the environment. That is not bleak. It is astonishing. It means your very existence is a dance with the arrow, not a defeat by it. So does the universe have a future that grows old like us? In one sense, yes. Stars will dwindle. Galaxies will drift beyond reach. The cosmos will become darker, colder, more uniform. In another sense, the question reveals how human we are. We imagine the universe as a creature with a lifespan, because we ourselves are creatures with a lifespan. We project biography onto the sky, but perhaps that projection is not an error. Perhaps it is a clue. Because the universe did not need to produce minds that ask about time. And yet here we are, made of ancient stardust, wondering where the river flows. So let me leave you with a final image to carry into the next part of the video. Picture the universe as a vast library whose pages are being written as you read them. The ink dries instantly behind you. Ahead, the paper is still blank, not because the future is empty, but because it has not yet become recordable. And that is the arrow of time in one sentence. The past is what has left a trace. The future is what has not. And now the question that opens the door forward. If our memories only exist behind us, and the universe itself seems to be aging toward a quieter state, what does that suggest about where all this is going? What kind of ending does a cosmos with an arrow of time actually allow? What if the universe does not end with a bang at all? What if it ends the way a lamp ends at the edge of a long night? Not with a crash, not with a final scream, but with a slow dimming that almost feels like mercy, a soft retreat of warmth, a patient surrender of structure. And if that is true, if everything we see is already on its way to becoming quieter, colder, more spread out, then the question is no longer only scientific. It becomes intimate. It becomes personal, because the sky is not just above us. It is a mirror of what all things do when time keeps walking. Let me start with a single image you can hold in your mind. Picture a campfire late at night. At first, the flames leap like bright animals, restless and hungry. They lick the air, they throw sparks, they speak in little crackling syllables. Then the logs slump inward. The flames shorten. The light becomes amber. Then the fire becomes embers, glowing like sleepy eyes. Then the embers become ash. No drama, no applause, just a gradual loss of pattern into stillness. That is one of the most important metaphors in cosmology, because stars are fires too, and galaxies are fields of fires. And the fate we are talking about is not a sudden collapse. It is the long, slow cooling of the cosmic hearth. Scientists have a name for the direction in which all of this moves. They call it the arrow of time. And one of the clearest voices on that subject, Arthur Eddington, left behind a line that still echoes through physics classrooms and late-night thoughts alike. So far as physics is concerned, time's arrow is a property of entropy alone. Thanks for watching. Entropy is a difficult word until you feel it. Entropy is what happens when a neat stack of cards becomes a scattered mess on the floor. Entropy is what happens when perfume spreads through a room until you cannot point to where it started. Entropy is what happens when order, without anyone attacking it, simply relaxes. The universe does not need a villain to fall apart. It only needs time. Now let us walk forward carefully, step by step, in a way your audience can actually see. First come the stars. Stars feel eternal because our lives are short. We look up, and the constellations look unchanged. We make stories out of them. We trust them. But every star you see is spending something. A star shines because it is burning the difference between what it is and what it could become. It converts dense fuel into light and heat. It turns structure into radiation. And that conversion is beautiful, but it is also one way. Like money leaving a wallet, it does not return on its own. Small stars are the patient ones. They burn slowly, like monks of the cosmos who refuse extravagance. They can glow for timescales so long that the human mind almost slips off the numbers. Large stars are the opposite. They blaze like performers who know the show will be short. They live fast. They die young. Sometimes their deaths are spectacular. Supernovae that scatter the heavy elements that later become planets, oceans, bones, and brains. But even that spectacle is part of the same quiet trend, because the explosion does not preserve order. It disperses it. It spreads it into the dark. And when the last generations of stars have burned through the easy fuel, the sky changes its character. It becomes a museum with fewer and fewer exhibits, fewer bright lights, fewer active furnaces. The universe does not stop existing. It simply stops producing new fireworks with the same ease. Here is where we slide naturally from stars to planets, because planets are children of stars. A planet is not a light source. It is a memory of heat. It begins warm because it is born from violence, collisions, compression, radioactive decay. In its youth it churns. It cracks. It breathes volcanoes. It moves continents like slow thoughts. But over immense time, a planet leaks its warmth into space. It cools the way a cup of tea cools on a table, except the table is the vacuum, and the cooling lasts eons. The core loses energy. The mantle stiffens. The surface becomes a quiet shell. And the world grows still, not because it was defeated, but because it finished spending what it had. A simple example helps people feel this without equations. Look at the moon in your mind. It is not shattered. It is not burning. It is not alive with weather. It is calm, scarred, and mostly silent. That is not an accident. That is what small worlds do when they cannot hold heat forever. Now enlarge that idea to countless planets, countless moons, countless once warm surfaces. A slow parade of worlds transitioning from active to quiet, from dynamic to dormant, not in a day, not in a century, but across ages that make human history look like a blink. From planets we drift, almost inevitably, to the architecture that holds them, the star system. A solar system is a dance. Gravity is the music. Orbits are the choreography. And for a long time, that dance can be stable. But stability is not sameness. As a star ages, it changes. It can swell. It can shed mass. It can throw off its outer layers like a breath in cold air. And when a star changes, the entire gravitational choreography adjusts. Some worlds may be swallowed. Some may be pushed outward. Some may be flung loose, becoming wanderers, rogue planets traveling the dark without a sun to belong to. Imagine a family home where the central fireplace is dying. People drift from room to room. The house does not explode. It empties. And that emptying is its own kind of ending. Now, widen the camera again. From the scale of star systems to the scale of galaxies. Galaxies feel like monuments. They look fixed, carved into the deep sky. But galaxies are not statues. They are rivers. They flow. They collide. They merge. They pull apart smaller companions. They trade stars like drifting embers in a vast, slow wind. Over unimaginably long time, the internal structure of galaxies can change. Star formation can slow as gas is used up or heated or ejected. Spiral arms can blur. Brilliant regions can dim. And once again, the theme returns. Not loud, not sudden, gradual, patient, silent. This is the moment to introduce an idea that is deeply educational and also emotionally powerful. The fate of structure is connected to the fate of difference. In physics, useful change happens because there are contrasts to exploit. Hot and cold, dense and diffuse, high pressure and low pressure. A waterfall can turn a wheel because there is a height difference. A steam engine can run because there is a temperature difference. Even life itself functions because cells maintain gradients, tiny differences across membranes, like little walls holding back the flood. But as the universe expands and cools and spreads out, those differences become harder to maintain. The cosmic waterfall becomes flatter. The cosmic engine loses pressure. The universe becomes more uniform, more even, more calm. And calm, in thermodynamics, can be another name for inability. Not inability to exist, inability to build new complexity easily. Lord Kelvin expressed this mood in a line that still feels like a bell in an empty hall. There is at present in the material world a universal tendency to the dissipation of mechanical energy. Things first, dissipation is the key word. Not destruction, not annihilation, dissipation, a spreading out, a smoothing, a softening of peaks into plains. At this point, your narrative can become almost meditative, because the science itself is meditative. It teaches patience, it teaches scale, it teaches humility. It says, look at the sky and understand that endings are not always events. Sometimes endings are trends. Sometimes endings are slow enough that they look like normal life, until you zoom out far enough to see the direction. Now bring your audience closer again, because a story about the far future must still land in the human heart. Carl Sagan gave us a line that does exactly that, bridging credibility and wonder without forcing either. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. Thanks for watching. Think about what that implies. The same processes that will one day leave the universe colder are the processes that made us possible. The same star furnaces that will go out are the ones that forge the carbon in our cells and the oxygen in our blood. So when we talk about the universe fading, we are not narrating a distant tragedy. We are reading the long arc of our own origin story. And now we arrive at the quietest but most haunting idea of all. Even the darkest, most seemingly eternal structures may not be eternal. Black holes look like the ultimate vaults, storing mass and memory behind a horizon. Yet Stephen Hawking, with his characteristic clarity, offered a sentence that changed how many people imagine the far future. Black holes ain't as black as they are painted. Thanks for watching. His work suggested that black holes can leak very slowly over unimaginable time, turning stored order into faint radiation. So even the last great monuments of structure may eventually soften into the background. Not with a crash, with a whisper. If you step back now, you can see the full chain in a single breath. Stars burn and fade. Planets cool and still. Star systems loosen and scatter. Galaxies dim and drift. Even the densest knots of gravity may slowly unravel into thin light. The end is not a final scene with dramatic music. The end is the music getting quieter until you realize you have been listening to silence for a long time. And here is the educational value that lands like a soft weight. The universe, as far as we can tell, rewards the present moment of complexity, because complexity is not guaranteed. It is a phase, a window, an arrangement of energy and matter that can only persist while gradients exist and structures can be maintained. That means this era, the era of stars and chemistry and living minds, may be precious in a very literal physical sense, not spiritually forced, not morally preached, physically rare. A brief season when the cosmos is capable of both beauty and witnesses. So when you speak to your audience, speak gently but firmly. Do not frame this as doom. Frame it as perspective. Because the fact that the universe trends toward quiet does not rob your life of meaning. It gives meaning a sharper outline. It makes wonder more urgent. It makes gratitude more rational. It makes curiosity feel like a duty to the moment we have been given. And now, let the hook tighten one last time, so viewers feel compelled to stay. If the universe is slowly losing its structure, if the ending is silence rather than spectacle, then the real mystery is not only where everything is going. The mystery is why we are here, now, in the bright middle of the story, able to look up and understand any of it at all. And that leads us forward, naturally, into the next section. Because if everything is moving toward quiet, if everything is slowly going somewhere, then we have to ask the question that sits at the center of the night. If everything is going, what is the destination? What if the universe is not a place we live in, but a story that is still deciding how it ends? Tonight, I want to begin with a question that sounds simple, yet keeps the best cosmologists awake in the quiet hours. If the cosmos has been expanding for almost all of its remembered life, what is it expanding toward? And what happens when it can no longer hold itself together? There are a few grand endings that modern science is willing to sketch, not as prophecy, but as possibilities drawn in chalk on a wind-blown stone floor. They are not equally likely, and none of them is certain, because the final chapter depends on numbers we are still measuring, and on physics that may still have surprises hidden in its deepest seams. But even uncertainty can teach us, because it forces the mind to compare, to test, to imagine, and to recognize what evidence can and cannot say. Carl Sagan once offered a line that feels less like a quote and more like a compass. We are a way for the cosmos to know itself. Nos Rauv. If that is true, then every attempt to picture the end of the universe is also the universe looking into a mirror, wondering what face it will wear when all the lights go out. And Richard Feynman gave us a discipline to hold that mirror steady. The first principle is that you must not fool yourself, and you are the easiest person to fool. Thanks for watching. So let us walk carefully, and let us treat each ending like a road sign in fog, useful, but not absolute. The first path is the one that sounds almost gentle until you realize how total it is. The universe cools, thins, and fades. This is often called heat death or the big freeze. Not because the universe becomes an ice cube, but because usable energy becomes harder and harder to find, like warmth leaking from a house with the windows cracked open to eternity. It begins with a simple truth that every human body already understands. Heat flows from hot to cold. Order tends to dissolve into disorder. Not instantly, not dramatically, but inevitably. Imagine a cup of coffee left on a kitchen table late at night. At first, it is alive with heat. You can feel it on your fingertips. Steam rises like a small ghost, but you do not see the heat leave. You do not hear it depart. And yet the coffee cools. The warmth spreads into the room until the room and the coffee share the same temperature. And at that moment, nothing much can happen without outside help. That is the heart of the big freeze, scaled up beyond comprehension. Stars are cosmic furnaces. They shine because they burn through fuel. When fuel runs low, the furnaces dim. In the far future, the sky becomes a museum after closing time. Galaxies grow darker. The last red dwarfs linger the longest, like embers that refuse to die, but even embers surrender. Black holes may remain, silent vaults of mass and memory, and even they may slowly leak away through processes we can barely test today. Stephen Hawking once described his ambition with a clarity that still stings with courage. My goal is simple. It is a complete understanding of the universe, why it is as it is, and why it exists at all. Thanks for watching. The Big Freeze does not answer why, but it does offer a lesson in how physical laws behave when given enough time. It tells us the universe may not end with a bang, but with a long diminishing, a candle lowering itself into darkness, not because it is attacked, but because it has done all the burning it can do. And yet, as we stare at that slow fading, another possibility steps out of the shadows, sharper, stranger, and more violent. The Big Rip. This is the ending in which expansion does not merely continue, it accelerates until it becomes a kind of cosmic tearing. To picture it, do not start with galaxies. Start with fabric. Imagine a sheet pulled outward from its corners. At first the weave holds. Then the tension rises. Threads begin to groan. If the pulling never stops, there may come a moment when the cloth does not stretch anymore. It tears. In the Big Rip picture, the force driving expansion grows so dominant that it overpowers the bonds that hold structures together. First, galaxies lose their grip on their stars. Then solar systems lose their grip on their planets. Then planets lose their grip on their own atoms. It is a staggered apocalypse, a countdown where each level of structure fails after the larger one has already surrendered. To make that vivid, imagine standing on a quiet shoreline. The sea is calm, the horizon steady. Now imagine the tide begins to rush outward, not in waves, but as if the ocean itself is being pulled into the sky. The boats strain at their ropes, then the ropes snap, then the wood splinters, then even the saltwater mist seems to separate into something thinner than air. That is the emotional shape of the Big Rip, not a collapse into nothing, but an unmaking into separation. This scenario depends on what dark energy really is, and whether it remains constant or changes with time. Right now, our best measurements suggest the expansion is accelerating, and we give that acceleration a name. But a name is not an explanation. Dark energy is like a label on a locked door. It tells you which door matters. It does not tell you what is inside. So, the Big Rip remains a could be, not a will be. Fried. But it teaches something educational and quietly profound. It forces us to ask what it even means for space itself to have dynamics, and it reminds us that the universe is not only made of objects, it is also made of rules, and those rules can shape destiny. If the Big Rip is the universe torn apart, the third path is the universe folding inward. The Big Crunch. This is the ancient dramatic ending. The one that feels like a myth retold in the language of equations. The universe expands, slows, stops, and then reverses. Everything that once rushed outward begins to fall back, as if gravity finally calls in all its debts. A simple way to feel this is to imagine throwing a stone upward into the air. At first it climbs, fast and confident. Then gravity slows it. It reaches a peak, a brief stillness where the future changes direction, and then it returns. The Big Crunch imagines the universe as that stone. But for the universe to fall back, there must be enough matter and energy to halt expansion, or dark energy must behave differently than it appears to today. So again, it is a possible road, not a guaranteed destination. And if a crunch happens, another idea sometimes follows behind it like a whisper, a bounce, a cycle, expansion, contraction, and expansion again, as if the cosmos inhales and exhales. Some researchers have explored whether a previous universe could have collapsed into the conditions that gave rise to our beginning, and whether the Big Bang might be less a birth from nothing and more a rebirth from something. This is where cosmology begins to resemble the oldest human intuitions. Not conspiracy, not certainty, but a pattern that feels familiar. Day becomes night. Winter becomes spring. Ash becomes soil. The question is whether the universe itself participates in such rhythms, or whether that longing for cycles is simply a human way of making peace with endings. Now, here is where the educational value becomes more than facts. It becomes a way of thinking, because each scenario teaches you to link observation to inference. The Big Freeze is connected to the second law of thermodynamics and to the long-term behavior of stars and black holes. The Big Rip is connected to measurements of cosmic acceleration and to the properties of dark energy. The Big Crunch is connected to the overall density of the universe and to how gravity competes with expansion. You can feel the method here. We do not choose endings because they are dramatic. We choose them because they are what happens when you extend known laws forward under different assumptions, and then you ask which assumptions match the sky we measure. This is why cosmology is both science and meditation. It trains humility. It teaches patience. It invites you to hold multiple possibilities without panic. The mind learns to say, I do not know yet, but I know what kind of evidence would move me closer. That is not weakness. That is strength. It is the same strength you use in life when you accept that certainty is rare, yet meaning is still possible. So how do we decide which road the universe is walking? We look at the expansion rate. We map how galaxies cluster. We study the afterglow of the early universe. We measure how light stretches as it travels. And we keep refining the story with each new instrument and each new data set, like archaeologists brushing dust from a carved inscription, revealing letters slowly, without pretending we already know the full sentence. And still, even if we learn the ending, the deeper question remains. What does it mean for creatures made of stardust to ask where stardust is going? If the universe ends in cold silence, does that make our brief warmth less important, or more? If the universe could tear itself apart, does that make love and memory small, or does it make them astonishing because they existed at all? If the universe could collapse and begin again, does that comfort us, or does it raise an even stranger possibility that we have been here before in some other form, in some other cycle, and that the feeling of wonder is an echo carried across cosmic ages? So let me bring us back to the hook that started this journey, because it is the thread that ties every scenario together. If everything is moving, where is it going? In the next part, we will take these three roads and place them against the best clues we currently have, so you can feel which path the evidence gently leans toward, and which mysteries remain stubbornly unopened, like doors in a temple corridor where the torchlight cannot quite reach. What happens when the universe keeps expanding so long that even the sky forgets it ever had neighbors? Imagine a night where no new star is ever born. Imagine a horizon so empty that the word distance loses meaning. And ask yourself this: if everything is moving away, What is left when nothing can be seen moving at all? At first, this future sounds like science fiction, yet it is a natural extension of what we already measure in the present. Galaxies are not simply traveling through space like ships crossing an ocean. Space itself is stretching. The faster it stretches, the more the universe hides its own story, not by censorship or violence, but by geometry, by the quiet mathematics of an expanding cosmos. To picture it, begin with a simple image. Stand on a shoreline at dusk. A fleet of lanterns drifts away on the dark water. At first, you can still count them. Then you see only a scattered handful. Then only one. Then nothing at all. The lanterns did not vanish. Your ability to receive their light did. That is what an accelerating universe can do. As expansion continues, distant galaxies slide beyond a limit called the cosmic horizon. Not a wall of stone, not a barrier you can touch, but a boundary of reach, a distance beyond which light released today will never arrive. It is as if the universe is slowly closing a book by pulling the pages apart. The words remain inked in the paper, but the reader can no longer open to the chapter. In that far era, even the brightest beacons fade in a more subtle way. Light loses energy as space stretches. Its wavelength grows longer. A fierce blue glare can become a dim red ember, then an invisible whisper in the microwave. Then a radio murmur spreads so thin that it is nearly indistinguishable from silence. The past does not explode. It simply grows too faint to be heard. There is a line from Carl Sagan that fits here. We are a way for the cosmos to know itself. Wudge. But what if the cosmos becomes a place where knowing is no longer possible? What if the lights that carry information decay into darkness, and the stage becomes so empty that even curiosity has nothing to grip? Now let the imagination travel farther still. Not millions of years, not billions, but stretches of time that make the age of our civilization feel like a single breath. Stars like the sun burn for billions of years, yet even that is temporary. In the long run, the universe uses up its easy fuel, the bright age ends, and the night begins to dominate the calendar of existence. You can make this vivid with a household example. Picture a campfire at the end of a long gathering. Earlier the flames were tall, faces were lit, stories flowed. But as the wood is consumed, the fire collapses into embers, the warmth weakens, and the light that once reached the trees no longer reaches your hands. In the final stage, only a faint glow remains, then ash, then a cold ring of stones around nothing. In cosmic terms, the embers are the last red dwarfs. Small, stubborn, long-lived, they can shine for trillions of years, but even they will eventually dim. When the last stars go out, the universe becomes an archive with no lamps. And that is where the loneliness deepens, because loneliness is not only the absence of life, it is the absence of connection, the absence of signals, the absence of any outside voice to answer your own. There is another quote that echoes like a footstep in a cavern. Stephen Hawking once said, "Remember to look up at the stars and not down at your feet." When good elimination in that far future, looking up may reveal almost nothing, not because the universe is gone, but because it has stretched itself beyond testimony. And here is the strangest educational lesson hidden inside this vision. The universe does not only evolve in what exists, it also evolves in what can be known. Knowledge is not just a function of intelligence, it is a function of available evidence. If an observer is trapped inside a tiny gravitational island of matter, they may conclude the universe is small, static, and empty. They may never suspect that billions of galaxies once blazed beyond their sky. They might invent myths of a lone world, or claim their local cluster is all that ever was. not because they are foolish, but because the data has been erased by expansion, so the future can rewrite the past without changing a single event. It can hide the Big Bang behind the thinning of ancient light. It can hide the cosmic microwave background by redshifting it beyond detection. It can hide other galaxies by placing them forever out of range. And that teaches something uncomfortable. Cosmic truth can be time-dependent, not in its reality, but in our access to it. Freeman Dyson once offered a thought that feels both hopeful and haunting. Time is nature's way of keeping everything from happening at once. In the deep future, time may also be nature's way of keeping everything from being remembered at all. Now bring the lens closer. How would a living civilization experience that era? Suppose a distant descendant species survives around a long-lived star. Their night sky might show only their own galaxy, or perhaps only their local cluster of stars. No Andromeda, no grand tapestry of deep-field galaxies, no evidence that space once teemed with island universes. The universe would appear like a solitary campfire in an endless dark plain, a single circle of light, surrounded by a silence that has no edge. And even within their own galaxy, change continues. Stars drift, orbits evolve, encounters fling worlds into interstellar darkness. Eventually, some remnants may dominate. White dwarfs cooling, neutron stars spinning down, black holes slowly evaporating over unimaginable durations. Each process is slow, each is patient. Each feels like the universe practicing the art of letting go. This is why the feeling of loneliness in such a future is not merely emotional. It is physical. It is informational. It is the loneliness of a cosmos where messages no longer travel, where the past cannot reach the present, where the present cannot call to the future, where the great conversation of starlight becomes a closed mouth. And yet, if we are honest, there is a strange peace in that picture, a meditative stillness, a reminder that the universe is not obligated to be dramatic for our sake. It does not need fireworks to conclude a chapter. Sometimes it ends with the softest possible gesture, a gradual dimming, a long exhale, a fading of the last usable light. So what do we do with this knowledge now? Not as despair, but as clarity. Because we live in an era where the cosmos is still readable, where galaxies still appear like scattered cities at night, where the microwave background still hums like a fossil heartbeat, where telescopes can still pull ancient photons into a human eye. In a sense, we are living in the brief luminous interval when the universe still allows witnesses. And that brings us back to the question you cannot unhear once it takes root. If everything is moving away, if light itself is tiring, if the sky can eventually forget its own history, then what does it mean that you are here now, awake, listening, able to look outward and reconstruct a story billions of years long? In the next part, we will follow that story one step deeper, because if everything is going, then the real mystery is not the motion. It is the destination. So let us continue and ask it plainly. If everything is moving, where is it going? What if your entire life, every love you have ever held, every fear you have ever hidden, is only a brief sparkle on a cosmic shoreline? What if the universe barely notices us, yet somehow we are the part of it that can notice back? Step back for a moment and picture Earth from far beyond the moon, then far beyond the outer planets, until our world becomes a pale bead suspended in darkness. In that perspective, human history shrinks into something smaller than a breath, and even our longest civilizations become thin rings in the trunk of time. Carl Sagan once called our home a mote of dust suspended in a sunbeam, a AMSA. It is not an insult, it is an invitation to humility. And humility, when it is honest, can become a kind of strength. Now let us widen the lens just enough to feel the strange arithmetic of existence. The universe has been expanding for billions of years, and it will likely continue long after our species is gone. Stars are born, they burn, they dim, and they disappear, like candles in a cathedral where no priest remains to count the flames. Galaxies collide in slow motion, not with explosions you can hear, but with tidal dances that take eons to complete. Even the most solid-looking things are temporary arrangements, beautiful and fragile and passing. And here is where the question tightens, like a thread pulled through the heart. If everything tends toward change, toward cooling, toward dispersal, toward eventual decay, then what is the meaning of a single human life? What does it mean to love, to build, to learn, when the cosmos itself seems to drift towards silence? Stephen Hawking offered a simple compass for that kind of darkness when he said, "Remember to look up at the stars and not down at your feet." APN, so APNs. That line is not just poetry, it is a strategy for the mind. Because when you look up, you are not only looking outward, you are also looking inward. You are confronting the fact that meaning is not always handed to us by the universe like a stamped certificate. Sometimes meaning is something we cultivate, like a flame protected from wind. And the wind, in this case, is the cold honesty of impermanence. Think of a sand mandala made by monks, painstakingly arranged grain by grain, color by color, pattern by pattern. The beauty is real, even though it will be swept away. Its disappearance does not cancel its value, it completes it. In the same way, a human life can be meaningful, not despite its briefness, but because of it. This is not wishful thinking, it is a deep lesson embedded in physics and in experience. Entropy, the tendency for usable energy to spread out and for ordered systems to drift toward disorder, is not a villain, it is a rule of the game. A warm cup of coffee cools. A campfire becomes ash. A battery drains. A star eventually runs out of fuel. Even mountains flatten, given enough time, because time is patient and gravity never stops working. So where do we fit inside this relentless story? We fit in the rare place where order can temporarily bloom. We are like a whirlpool in a river, a coherent pattern made of moving water. The whirlpool is not separate from the river. It is the river, arranged for a moment into a recognizable shape. In that metaphor, you are not a stranger in the universe. You are a local pattern of the universe, briefly aware of itself. Albert Einstein once said, "The most beautiful thing we can experience is the mysterious." So in Zavences, that mystery is not a gap in knowledge to be mocked. It is a horizon that keeps us walking. And the strange fact is that the universe produced creatures who can ask questions about the universe. This is not guaranteed by any law that we know of. It is simply what happened, at least here, at least now. To make this feel concrete, imagine a simple classroom analogy. If the age of the universe were compressed into a single calendar year, modern humans would appear only in the last minutes of the last day. Every empire, every library, every cathedral, every war, every song you have ever heard would be a flicker at the very end. That is how brief we are. And yet, within that flicker, we write symphonies, we map galaxies, we care for children, we forgive, we regret, we hope. Now notice what this implies. Meaning is not measured only by duration. A short poem can change a life. A brief kindness can redirect a future. A single discovery can reshape a civilization's sense of reality. Duration matters, yes, but it is not the only metric. Here is another example, quieter and closer to the skin. Think of an elderly person holding the hand of someone they love in a hospital room at night. Outside, the world continues as if nothing has happened. Cars pass. Streetlights hum. The planet spins. But inside that room, the universe has narrowed into a single human moment, and that moment can carry more meaning than 1,000 empty years. The cosmos may not grant us a permanent monument, but it grants us the capacity to value. It grants us consciousness, and with it, responsibility. Richard Feynman captured something of this paradox when he said, "I think nature's imagination is so much greater than man's." Bentley Bradagnott. And still, even with our smaller imagination, we can choose how to live inside nature's vastness. So if everything is heading toward dispersion, what becomes the educational value of knowing that? It teaches proportion. It teaches gratitude for conditions that allow life at all. It teaches intellectual honesty, because pretending we are eternal makes us reckless. It teaches compassion, because when you realize how brief everyone is, cruelty looks even more absurd. There is a meditative lesson here, and it is not sentimental. When you accept impermanence, you stop demanding that life be permanent in order to be precious. You start paying attention. You start listening as if the moment matters, because it does. You start treating relationships like living things, not like objects you can store forever. And slowly, the cosmic story becomes less of a threat and more of a teacher. The stars do not mock us by dying. They demonstrate the cost of shining. They show that brilliance is always paid for in fuel. They show that beauty is a process, not a possession. If you want one last image to hold in your mind, imagine standing on a beach at night while the tide goes out. The water withdraws, and the shore grows wider, and the world feels larger and emptier. But in the wet sand, tiny organisms move, shells glint, patterns form, and life continues to make meaning in the space that remains. We may be like that, small, brief, and luminous against a vast retreating sea. And that brings us back to the question, sharper now, almost tender. If everything is moving toward change, toward dispersal, toward eventual quiet, then perhaps meaning is not a destination at the end of time. Perhaps meaning is the way we travel. Perhaps it is the care we take, the truths we pursue, and the wonder we refuse to abandon. So now, as we narrow the lens again toward Earth, toward your own day, toward your own breath, we arrive at the doorway of the next part. Because if everything is moving, if every atom is on a journey written by physics and time, then we have to ask the most haunting question of all. If everything is going, where is it going? What if the question, where is everything going, is not a question the universe can hear? What if it is only a question we whisper to ourselves, because our minds are built like arrows? We aim, we plan, we seek endings that make the journey feel safe. At first glance, the cosmos seems to agree with us. Galaxies are fleeing, light is stretching, space is swelling like a lung in slow motion. It is tempting to imagine a destination, a final shore, a last page. But the deeper you follow the evidence, the more the universe begins to feel like an ocean rather than a road. And an ocean does not go anywhere in the way a traveler goes somewhere. An ocean changes. This is where the idea becomes quietly radical. Maybe going is a human metaphor. Maybe the universe is not heading toward a goal. Maybe it is simply transforming without end. Not progress, not purpose, not a finish line, just the ceaseless rearranging of energy and form, like waves that rise and fall without needing to arrive. If you stand at the edge of a dark sea at night, you can feel it. The water does not chase a destination. It moves because motion is what it is. Each wave is born. Each wave collapses. And the ocean remains. That single image can teach more than 1,000 diagrams because it speaks to the intuition. The wave is not failing when it breaks. The wave is completing its nature. In the same way, a star is not losing when it burns its fuel. A star is doing what stars do. It is turning possibility into light, and yet we keep asking where it all ends because we live inside time. We feel the pressure of minutes. We watch candles shorten. We watch faces change. So we project our life pattern onto the sky. We imagine the universe as a story with a beginning and an ending because our own stories do. But the cosmos might not be written in chapters. It might be written in transformations. Carl Sagan once said, "We are a way for the cosmos to know itself." Dottle.com. That line matters here because it hints at a different relationship between us and the universe. Not as tourists demanding an itinerary, but as a small portion of the universe asking questions from inside its own unfolding. The longing for an endpoint may be less about physics and more about psychology, a desire to hold the infinite in two hands. Now, let us connect this to something you can picture clearly. Think about a river. You can point to its direction. You can say it is going to the sea. But the river is also evaporating. It is also seeping underground. It is also becoming cloud. So is it truly going anywhere? Or is it changing state after state, becoming what conditions allow? The universe may be closer to that second description. Cosmic expansion does not necessarily mean the universe is traveling toward a destination. It means the scale of distances is changing. And when distances change, the possibilities change with them. Gravity gathers matter into islands of stars. Radiation cools and thins. Black holes grow. Atoms form. Chemistry blooms. Life appears. Consciousness wakes up for a moment and asks what the whole thing means. None of this requires a final target. It requires only rules and time. Stephen Hawking offered a simple instruction that feels almost like a spiritual practice. Remember to look up at the stars and not down at your feet. Thanks for watching. Because when you look up, you begin to notice that the universe does not behave like a machine built for our comfort. It behaves like a vast process. And processes do not want things. They unfold. Here is another example that makes the point tangible. Watch a flame. A flame is movement made visible. It dances. It leans. It flickers. Ask yourself where the flame is going. It is not going anywhere. It is converting fuel into heat and light. It is shape without permanence. A living metaphor for transformation. A star is a flame on the scale of 1,000,000 Earths. It too is a conversion, not a journey to a destination. And if that is true, then the question changes. Instead of asking where everything is going, we begin to ask what everything is becoming. That shift is educational in the deepest sense because it trains the mind to think like nature. Nature does not promise conclusions. Nature offers patterns. Energy flows from concentrated to dispersed. Structures arise when conditions permit. Structures dissolve when conditions change. The universe is not a lecture with a final slide. It is a meditation in motion. Albert Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." Thanks for watching. This matters because even if the cosmos has no destination, it still has intelligibility. We can learn its rhythms. We can trace its echoes. We can build instruments that turn invisible wavelengths into images. We can read the fossil light of the early universe like a whisper trapped in ice. Understanding does not require a final purpose. It requires attention. Now let us return to the sea. Waves do not need a mission. They need wind. They need gravity. They need the shape of the shoreline. In the same way, galaxies do not need a goal. They need initial conditions. They need physical laws. They need time. And from those ingredients, patterns emerge that can look like a story. But a story is what we call it, not what it must be. So when someone asks, "Is the universe heading toward heat death?" Thanks for watching. Or, will everything end in darkness? That's siding, infaction, and the combated. The honest answer is that these are models of how transformation might continue under certain assumptions. They are not prophecies carved into stone. They are maps drawn from what we can measure today. And maps are always partial. That is not a failure of science. That is the humility built into real inquiry. If you want a final image to carry into the next part of this journey, picture a vast night ocean under moonlight. The surface is never still, yet the ocean does not hurry. It does not panic. It does not ask for meaning. It simply becomes wave after wave after wave. And perhaps the universe is like that. Not a traveler seeking a destination, but an endless becoming. So here is the question I want to leave ringing in your mind as we move forward. If the cosmos is not going anywhere, if it is only changing, then what does that make us? Are we passengers desperate for an ending? Or are we waves learning to recognize the ocean? What if the question, where is everything going, is not a question the universe can hear? What if it is only a question we whisper to ourselves because our minds are built like arrows? We aim. We plan. We seek endings that make the journey feel safe. At first glance, the cosmos seems to agree with us. Galaxies are fleeing. Light is stretching. Space is swelling like a lung in slow motion. It is tempting to imagine a destination, a final shore, a last page. But the deeper you follow the evidence, the more the universe begins to feel like an ocean rather than a road. And an ocean does not go anywhere in the way a traveler goes somewhere. An ocean changes. This is where the idea becomes quietly radical. Maybe going is a human metaphor. Maybe the universe is not heading toward a goal. Maybe it is simply transforming without end. Not progress. Not purpose. Not a finish line. Just the ceaseless rearranging of energy and form, like waves that rise and fall without needing to arrive. If you stand at the edge of a dark sea at night, you can feel it. The water does not chase a destination. It moves because motion is what it is. Each wave is born. Each wave collapses. And the ocean remains. That single image can teach more than 1,000 diagrams because it speaks to the intuition. The wave is not failing when it breaks. The wave is completing its nature. In the same way, a star is not losing when it burns its fuel. A star is doing what stars do. It is turning possibility into light. And yet we keep asking where it all ends because we live inside time. We feel the pressure of minutes. We watch candles shorten. We watch faces change. So we project our life pattern onto the sky. We imagine the universe as a story with a beginning and an ending because our own stories do. But the cosmos might not be written in chapters. It might be written in transformations. Carl Sagan once said, "We are a way for the cosmos to know itself." One of the players of the Tang. That line matters here because it hints at a different relationship between us and the universe. Not as tourists demanding an itinerary, but as a small portion of the universe asking questions from inside its own unfolding. The longing for an endpoint may be less about physics and more about psychology, a desire to hold the infinite in two hands. Now let us connect this to something you can picture clearly. Think about a river. You can point to its direction. You can say it is going to the sea, but the river is also evaporating. It is also seeping underground. It is also becoming cloud. So is it truly going anywhere? Or is it changing state after state, becoming what conditions allow? The universe may be closer to that second description. Cosmic expansion does not necessarily mean the universe is traveling toward a destination. It means the scale of distances is changing. And when distances change, the possibilities change with them. Gravity gathers matter into islands of stars. Radiation cools and thins. Black holes grow. Atoms form. Chemistry blooms. Life appears. Consciousness wakes up for a moment and asks what the whole thing means. None of this requires a final target. It requires only rules and time. Stephen Hawking offered a simple instruction that feels almost like a spiritual practice. Remember to look up at the stars and not down at your feet. Only one. Because when you look up, you begin to notice that the universe does not behave like a machine built for our comfort. It behaves like a vast process. And processes do not want things. They unfold. Here is another example that makes the point tangible. Watch a flame. A flame is movement made visible. It dances. It leans. It flickers. Ask yourself where the flame is going. It is not going anywhere. It is converting fuel into heat and light. It is shape without permanence. A living metaphor for transformation. A star is a flame on the scale of 1,000,000 Earths. It too is a conversion, not a journey to a destination. And if that is true, then the question changes. Instead of asking where everything is going, we begin to ask what everything is becoming. That shift is educational in the deepest sense because it trains the mind to think like nature. Nature does not promise conclusions. Nature offers patterns. Energy flows from concentrated to dispersed. Structures arise when conditions permit. Structures dissolve when conditions change. The universe is not a lecture with a final slide. It is a meditation in motion. Albert Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." Thanks for watching. This matters because even if the cosmos has no destination, it still has intelligibility. We can learn its rhythms. We can trace its echoes. We can build instruments that turn invisible wavelengths into images. We can read the fossil light of the early universe like a whisper trapped in ice. Understanding does not require a final purpose. It requires attention. Now, let us return to the sea. Waves do not need a mission. They need wind. They need gravity. They need the shape of the shoreline. In the same way, galaxies do not need a goal. They need initial conditions. They need physical laws. They need time. And from those ingredients, patterns emerge that can look like a story. But a story is what we call it, not what it must be. So when someone asks, is the universe heading toward heat death? Infallen Divire minus, or will everything end in darkness? We have Enter Vary. The honest answer is that these are models of how transformation might continue under certain assumptions. They are not prophecies carved into stone. They are maps drawn from what we can measure today. And maps are always partial. That is not a failure of science. That is the humility built into real inquiry. If you want a final image to carry into the next part of this journey, picture a vast night ocean under moonlight. The surface is never still, yet the ocean does not hurry. It does not panic. It does not ask for meaning. It simply becomes wave after wave after wave. And perhaps the universe is like that. Not a traveler seeking a destination, but an endless becoming. So here is the question I want to leave ringing in your mind as we move forward. If the cosmos is not going anywhere, if it is only changing, then what does that make us? Are we passengers desperate for an ending? Or are we waves learning to recognize the ocean? We end with humility. Perhaps we will never know where the universe is going. Perhaps the question itself reaches beyond what any instrument or equation can answer. And yet, the act of asking is not wasted. It is part of the journey itself, a quiet movement of curiosity through an endless cosmos. So as you carry this thought with you, ask yourself gently, if the universe is still unfolding, what kind of question do you want to be within it?